So here's a little bit more complex of a problem, again having to do with a freaking tree. So a bird watcher discovers a hawk's nest in a tree some distance away. She wants to determine its height, that is the height of the nest above the ground, right? So she measures the angle from the level ground to the nest at 40 degrees. After approaching 25 feet closer to the base of the tree, she finds the angle to be 52.5 degrees. So how high is the nest? Off the ground, of course. So I need to draw a picture, of course. Now this tree is not chopped up or, tilting over or anything. You can't do this problem unless you assume the tree is vertical. Okay, so let's just assume the most common thing, the tree is vertical. So I would have my tree, and the first measurement is taken, it's the nest. So this is just the part of the tree up to where the nest is. I don't care about the top of the tree, right? Just where the nest is. And the first measurement that she makes is the angle is 40 degrees. Okay, so that's what I drew there. I don't know the height, so I don't label it. Well, it wants to know the height, so I could label the height like h right here. I could do that now if I want. I don't know this distance here at all, and I'm not given that distance. Notice. What I am told is that if she approaches 25 feet closer to the tree, so she goes from here over 25 feet, then the angle to the nest will be 52.5 degrees. So that is 25 feet. Then that gives you 52.5 degrees. And now it's asking you for the height. So you're probably not going to be able to do this with just one formula, just like instantly get the thing. So it's like a two-part problem, it looks like. Or maybe I have to figure out, I'm probably going to use opposite over adjacent, which is tangent theta, right, with two different thetas. But they're two different adjacent lengths. And one of them is not 25, because that opposite over adjacent only works for right triangles. So I have to use this big triangle as one triangle, as that right triangle there. And this right triangle is the other right triangle, because you can't use the trig functions, well, without knowing a whole lot more than we do now, with a triangle that's not a right triangle. So this little one here is not a triangle I'm considering. Okay? That's not going to help me with this problem. Okay, so that's the key thing to realize here. So I don't know what this distance here is at all. And since I'm going to use opposite over adjacent, I kind of need to label that something. So I probably just call it x from here to here. Yeah, so I call that x. So the base of the larger triangle is 25 plus x, right, from there to there. And the base of the smaller triangle is x. Okay, so I should be able to get two equations out of this. So tangent 40 is opposite of the big triangle, right? So 40 degrees is for the big triangle. So opposite of the big triangle over the adjacent of the big triangle, which is x plus 25. And I just wrote that down. I'm just going to write down one piece at a time and see if I can make everything work out. Okay? I'm not going to try to write down one single equation all at once. That's kind of silly. So I want to solve for h actually. But I think I'm solving for x here. Why? Because I'm going to have another equation with an x in it, and then I can substitute. So that's probably what I'm doing here. Yeah, that's what I'm doing. Now, maybe you don't figure that out until you write out your next equation. That's perfectly fine, right? I just know I'm going to write out another equation. It's going to be tangent of 52.5 degrees equals h over x, opposite over adjacent of the little triangle, right? So that's what I'm going to write out now. Tangent of this is the opposite of this triangle, h over the adjacent of this triangle, which is x. So that's a second equation, the separate equation. You see, now I could just plug that value. I could solve for x here and plug it in, or I could plug the other one in here. I think it probably would have been easier to, I don't know. You can solve these in different ways. The key thing is to get these two things correct. Once you've got that, you're trying to find h, so you want to eliminate x. If you accidentally eliminate h and get x, then you can just plug it in to one of these and solve and get it. It's just a long way around. So I really want to eliminate the x. So I could do that here by just setting these two equations equal to each other, because I solved them both for x. And there's other ways of doing this as well, of course. But these two should be the same. Maybe you called this something other than x, but maybe that's something other than h. I don't know why, but maybe you called it y. But you know, basically your equation should be these two here. And then you just have to solve for h. There's two equations, two unknowns. So you just use substitution. So I just set the two formulas. Since they're both equal to h, these expressions are both equal to h, this one and this one. I'm sorry, are both equal to x. I can set them equal to each other. And I get this, and I have to solve for h. And you don't have to write out all of this. You can actually just find these numbers. But I would write out like 5 digits for each of the trig functions, because when you're going to take a trig function and then, or anything that's rounded off and then compute with it, you want to keep extra decimal places. So I would either round it off to 5 decimal places or put it in a memory in your calculator if you know how to do that. So I get this, and that's just a number. It's h times some number that's on your calculator, right? Some number on your calculator there. And then you just divide that out, across and multiply this number, whatever this number is. Like I said, just round it off to 5 decimal places, and it just goes down here. So this is what I would do. I would use this little store, that's short for storage, stow, with the arrow. And it means you're gonna store, and then you use the green button, and then the letter A, so you're just storing it in memory A. And then when you type it out to compute it, you can just write h equals negative 25 over A. And then you don't have to worry about rounding it off too early or something and getting round off error. And they would probably tell you how many decimal places. I forgot to put how many decimal places to give the answer in. But, you know, maybe a tenth of a foot. Not more than that. 59 would, because I didn't tell you how much to round it off, 59 would be fine as well. Because again, how accurate are you going to be? You know, it depends on how accurate your instruments are, and we don't really know that. We weren't really given that information. Okay, so that might seem kind of complicated, but just think it through and make sure that you got the ideas down. Because you could be given something just like this, or you could be given something that's different, but it's similar in how one figures it out. The thought process is similar. So you want to make sure that you have the thought process down so that you don't get off track, or at least you're less likely to get off track if you're given a somewhat different problem to solve. And that is the end of the lecture for that section. Section 6.2.